Okay, so looking at this thing here, let's begin chapter 1. And like I mentioned to you guys yesterday, hopefully we can go through chapter 1 a little bit quicker or faster than usual, because chapter 1 is a lot of definition. Why? So again, you guys can read it. If you guys did the homework, if you guys watched the video or attempt the homework on Connect Math, you should see all this definition. So again, I just gonna jump into the key terminology, and then we will go from here and see if you guys have any question related to this terminology. So again, the first thing we have is statistic, right? You got to take a class. So what is statistic? Basically, in short, statistic is just basically the study of a collection of information, collection data, describing the data, and then later on, we have to draw a conclusion from the data or from your information. So chapter 1, chapter 2, chapter 3, and chapter 4 is basically collecting your data, collecting data and describe the data, try to present the data, right? And after the midterm, that is when we start to draw a conclusion. We try and make a test to see if our data work out the way we want it to be, or does our data answer the question we want to ask. Okay, so again, that's basically what statistic is in terms of just collecting, organize, and present your data. And then after that, we make a conclusion out of the data by perform some testing. So the two most important things in statistic is population versus sample, right? So the population is basically a collection of everything that you can collect in terms of all the information related to whatever the subject that you want to collect, and vice versa. The sample is just basically a subset of that population. So again, for instance, if you want to collect the age of all Delgado students, well, the population that I'm talking about here, it will be the Delgado student. But again, it is massive, right? We cannot collect all of the Delgado student age. So what can you do? Well, you can collect the City Park campus student, right? Or you can collect the age of the Math 203 student, right? That will be your sample. That will be a portion of the population, right? So the population is basically the entire individual that you want to collect, and the sample is just a portion of that population. Okay, so again, as you will see, these two items, population versus sample, you will see that these two things will bring us, every single chapter is will bring up population sample. And again, later on, you will have to know the difference between population versus sample, okay? And the two things that describe the population and the sample is, if the number illustrate or associate with the population, we say that a parameter, and the number associated with the sample, we call that statistic. And again, if you see that we are in statistic class, so as you can see, most of our data will be dealt with sample information, right? Because again, statistic is the number represent a sample. So again, the first thing we have, which is again, if you try to do the homework yesterday, this is probably, you will run into this in chapter 1, which is again, determine which of this number, the number described is a statistic or a parameter, right? So the average age of the employee in a certain company is 35 years old. So the number 35 years, what does this number 35 represent? Is it represent a statistic, the number, illustrate a sample, or is it represent the parameter, the number illustrate or illustrate the population? So looking at this thing here, is the employee, is that our parameter or statistic, or is this a population information or sample information, right? So looking at this thing here, hopefully you guys will say that is a parameter, right? Parameter, and again, you will say, wait, why is a parameter? Because again, the employee of this company, that is all of the individual that we want to collect, right? Which is, again, that is our population. Our population is the employee. So that is a because of the employee, that's why it's a parameter, right? And one thing that you will see, you will see that after this question here, if you see this question in a survey, you can stop right there, ladies and gentlemen. If anything say in a survey or in a poll, that will be your statistic. You will say, wait a minute, why is statistic? Because the survey does not include every people, right? Did you took this survey, or because they say in a survey, which is it's just a portion of people answer the survey, right? So again, in a survey of 450 high school students, 45% of them say they do not intend to enroll in college, which is, again, what does the 45% represent? Which is, this is your statistic, because anything in terms of a survey or the poll or something in terms that not everyone answered that survey, right? It's just a small portion of something answer the survey. So that's why if you see that in a survey or in a poll, that will be your sample item, because it does not include every single people. So again, because it's a sample item, that's why it's a statistic, okay? Similarly, which is, hopefully you guys see that of the students enrolled in Delgado, 82% are full-time students. So what does the number 82% of full-time student represent here? Well, again, looking at this thing here, is the student in Delgado, is that my population or my sample, right? So again, 80% of the student enrolled in Delgado, which is the student at Delgado, is my population, right? Again, like I mentioned earlier before the slide, if I want to collect all of the Delgado age, the student in Delgado, which is, again, that would be my population, which is, again, the student at that college, right? You probably say, wait a minute, Mr. Tran, Delgado is just one college out of every single college in America, right? But we are not comparing the college among colleges, right? I'm not comparing Delgado versus BRCC or versus any other college. I'm right here. The student is at Delgado, which is, that will be the information I want to collect. And again, because of that, is the only information I want to collect. Delgado is the main item, which is, that's my population. And again, the reason I give you C and B is not always the percentage is a parameter or percentage is a statistic. Okay, so again, you have to read your question, and hopefully you see that in D, after I mentioned that in a recent poll, we can stop here. Doesn't matter what number come after this. In a recent poll, if there's a poll, if there's a survey, we know that this is our sample. And if it's a sample, therefore the number follow this 59% will be statistic. Again, 59% is a statistic number, or is the number describe your sample. That's why it's a statistic, not parameter. Okay. So like I say, when you do your homework, if you see that in a survey, you can stop that. Doesn't matter what number after that. In a survey, that is your statistic. In a recent poll, again, I didn't answer the poll, right? Did you answer this poll? Not everyone answered the poll. So that's why it's a sample. This doesn't include everyone, okay? So again, that's the difference between parameter versus statistic. And again, parameter represent population or illustrate population number, and statistic illustrate the sample. That's what you guys have to do. And one thing about this class, there will be a lot of, especially chapter 1, there will be a lot of those things that you have to verify if it's this or that, right? So again, question with this parameter or statistic number here. And like I say, I will have this slide for you guys on Canvas after. So the next thing I will go through a little bit fast. And if you did the homework, they have, again, sampling, different method of sampling, different method to collect your data, which is, again, simple random sampling is basically simply say that when you collect your data, when you try to collect your data, you have to be fair and every single one have to be randomized, right? Or you don't just focus on one group and not the other. Whatever information you try to collect, first they have to be random, meaning each person in your population or in your sample, they will have a same equal probability, equal chance of getting selected. Okay, so again, random sampling is basically tell you that each individual or each data have a equal chance of being selected or equal chance of being asked the question. Okay, so there are five type of sampling. There are 5 types of sampling, which is the first one is a sample of convenience. Sample of convenience is just like the name. It's just basically you go and you try to collect your data as your convenience, right? You don't go beyond what you have. Meaning, for instance, if you want to collect data, you want to ask people, do they like Pepsi product or do you like Coke product? So the first thing is you say, oh, let me just stay in front of Winn-Dixie, right? That's convenient to you. You just stay in front of Winn-Dixie. Whoever comes Winn-Dixie, you ask you, do you like Coke product or do you like Pepsi product B, right? Which is convenient to you. And again, which is, again, is not fair in the sense that if I don't go to that Winn-Dixie, I won't be included in your study. So it's just convenient. And on in your book, they have, like, if you want to test the brick, like you want to test if each brick have the same weight or same size, and they stack up, like stack very high, you cannot get the bottom brick. You just, select your data convenient to you, which is you just take the top brick and test it out. So again, convenient is they say not well defined because it's just sometimes you exclude the item or exclude the other variable. You just take whatever convenient to you. Okay, so the other 3 is a little bit well defined or a little bit better, which is a stratified sampling. A stratified sampling is basically you just divide your population or your sample into different groups, right? So for instance, if I want to collect the age of the Delgado student, and I want to know what is the average age of the Delgado student, instead of ask everyone, I would separate you into different strata, which is, let's say I say, okay, the accounting major here, the nursing major here, the math major here, which is I divide you into different strata in terms of different criteria. And then from there, I will select your data. So stratify is basically you divide into different layer of your either your population or your sample. And each of that layer have the same criteria. It's just that, either male, female, or age group and stuff like that. Okay. And again, clutter sampling is basically now, instead of going to collect everyone, we just kind of, for instance, if we want to survey, we just circle one region and go there and we circle one region and we go there and we just ask the survey, and whoever in that region, we ask the same question. The difference between clutter and stratify is stratify, each group have the same, not the same characteristic, they have different characteristics. It's just that you divide them into either a female group and a male group, or a sophomore, a junior, and a senior, meaning different layer, and then you ask that question. Clutter, meaning you just circle them, and again, that clutter can have both freshman, sophomore, junior, and senior, right? The clutter is basically you clutter them together. You don't separate them into different categories, I should say. Okay, stratify, you separate them to different category. Clutter, you just you put them in one clutter, and then that clutter can include whoever in that clutter is. But you ask the same question on each and every one. It's just that they are not different character or characteristic or in term of the strata, meaning specific freshmen by themselves, sophomore by themselves, junior by themselves, or senior by themselves. Okay, so pay attention in that when you do the homework. I think that is the only two thing that will confuse some students. The question is, verify if this is a stratify or a clutter. Stratify is each category separately. Full-time, part-time, something in terms of each category. Clutter, one circle, how many whoever characters in that circle is your sample or your population. Okay. The last thing, not the last thing, the second to last thing is systematic. Basically, you put to collect this thing here, you put your data into some system, right? Pretty much you say, okay, you list all of your sample 1 through 1,000, right, into some order, some system, and then you say, okay, I will randomly select the 7 position, right, the 7 person, the number 7, and every 4 position after that. Right, so you put in some systematic that you say, okay, I will start with number 7, and then every 4 position after number 7, meaning again number 11, number 15, number 19, number 23. I randomly pick a position and I take them out and test them and ask them a question. Right, so systematic here is a lot of like change, automobile testing, right? They cannot test every single car they produce, so they say, okay, for the 8 position and every 4 position after that 8, and they take it out, they test the airbag, they test the tire, they test everything, and that's where sometimes you miss, right? Sometimes the defected car is at the 9 position, but you start at the 8 and every 4 position after that. So sometimes the 9 car got defected, and that's why there's a lot of recall back then in terms of airbag or something, because you overlook something. You cannot test every single car because it's not practicable, right? You have like 10,000 cars, you don't want to test every single one of them, right? They try to cut short and they just test, okay, the 7 car and every 5 car after that, right? The 7, the 12, the 17, the 22, and so on and so forth. So that's why sometimes the defective car did not get tested, and that's why they have a recall and all those stuff. So those 3, the stratify, the clutter, and a systematic is pretty much those 3 are the best way to collect data. Right. The last one is not very not realistic, but it's not very reliable. It's a voluntary response. Just like the name, voluntary response is basically you ask question, you ask survey question that people volunteer to answer, right? Like the truck driver on the back, like, how is my driving? Please call 1-800. Most of the time, people don't call that number unless the truck driver drive very reckless, right? Road rage or something, and you call that number to complain. So most of the time, voluntary response is people more often want to complain than try to answer the question, right? So sometimes when you collect the data, when they volunteer, you may have very negative or bad information. It does not justify that item, right? So most of the time people call is when they volunteer to call, most of the time is they have bad experience, and then they call in and respond, right? You never call and say, oh, that guy drive very good, he stopped at every traffic light and make a signal, right? So again, that's what we have, which is, again, it's just the different type of sampling, different type of collecting data.